Hello, this is the team Matrix 4, represented by Zeman, Xiaotong, Kwa, and Ikram, presenting our idea of Easy Point. Around 60 million Americans, around 20% of the population, have a disability. Around 20 million of those Americans have difficulty lifting or grasping. This includes, for instance, trouble lifting an object like a bag of groceries or interacting with a mouse. So we wanted to make an application that better helped these individuals interact with the World Wide Web through innovative and cutting-edge machine learning applications. In front of you is a high-level diagram of our project. We created a Chrome browser that will interact with a socket connection, sending in information to OpenCV. On the top right, as you see, the Chrome browser is composed of the background script and the content script. The background script is the logic part of the extension, and the content script is the direct exposure to the HTML on website we're using. The Chrome extension constantly monitors the content, in this case the DOM density map, and communicates it to the OpenCV through socket connection. And now Xiaotong will talk to you more about OpenCV.
Hey, I'm Xiaotong. So regarding the face control sensor, we use OpenCV library and machine learning technique to achieve it. The machine learning algorithm helps us to detect the face and eyes of the image. And then we applied it to the webcam and capture the face movement. And we selected a point to control our cursor. Then we used another library called Pipe to control the mouse and map the face movement to the cursor movement. And then I will let C to introduce how he achieves the DOM part.
So throughout our past experience with maybe like gyro control or a kind of a point and shoot kind of controls mechanism, we realized that it is extremely hard to actually control with raw input from a analog input. So there needed to be some assistance from the software side. So we created this scheme using Chrome extension to build a DOM model density map of the content on the screen and build an algorithm that basically gravitates towards these heavy DOM stacked areas where the buttons, the links, and the important information regarding to routing on the page is sitting at. So we can show you a little bit through the Jupyter notebook we created to build this model. Okay, I can't click on a Mac. How do you do this?
Oh, you want to click where?
The Jupyter notebook.
Yeah, this is the Jupyter notebook.
Oh, okay. Okay, so regardless of that, so we actually started with a socket connection, like the above diagram, which talks directly from the Chrome extension to OpenCV. And then with this extension, we're passing this image, basically a density map of the actual content that's live on your browser. With this density map, basically the cursor will get pulled very slowly with the addition of the direction where the OpenCV command with the eye is pointing to, and with the sum of these vector together, we kind of lock on to the actual content while providing the freedom to traverse through the page also. So that kind of wraps up the technology part of this presentation, and after this we'll do a little demo. So how do we do the demo now? How do you stop this? And now we'll be doing a live demo on this page. We picked this page because it has a nice contrast between text, picture, and the links, which is kind of concentrated on the right side. We'll be showing how this control works as a cursor with the video, and also we will also be showing the snap into links. And with that, Shelton will continue to demo. So first we'll dump the actual DOM content into the density map. And now that the density map is dumped into the Python script with the socket connection, we'll start the socket connection. And Shelton is just enabling OpenCV. So right away you can see the cursor actually gravitate towards the actual link, and that is not Shelton doing it. She's simply moving her head slightly towards that direction, and it automatically snaps into these different highly concentrated DOM object areas, like these pictures and text links. And you can see it overshot a little bit, but it came back. And it's very easy to fix your cursor with this mechanism to a link that where you are most likely going to be clicking. And with that, we will show side-by-side kind of control. A little challenging there, but you can see Shelton is simply suggesting where the actual cursor will go, and it kind of just gravitates towards. You see that acceleration where it just gravitates towards the actual link. We can try one more time, moving up. And maybe to the right side of the text, closer to the phone number. And go down. You see the cursor is trying to lock onto these links. And all the way down, you can jump the cursor basically with a light suggestion. And there we go. And that kind of shows the intuitiveness of this kind of snap-on kind of interface. And that demo completes.